I'm going to introduce the topic of decimals, including decimal notation. Okay? So let me start by listing some examples of decimals. All right, so these are all examples of decimals. Okay, notice that they all have a dot or a period, whatever you want to call it. That's referred to as the decimal point of the decimal. All right. Some of the decimals have just a 0 to the left of the decimal point. Other examples have other numbers to the left of the decimal point, and they all have some numbers to the right of the decimal point. Okay? So what do decimals mean? What are they used for? These decimals are alternative representations of certain fractions. Okay? Let me repeat that. Decimals are nothing more than an alternative way to express certain fractions. All right? So if you already understand fractions, you're already a long way towards understanding decimals. All right? So what are the fractions that decimals are equivalent to? They're equivalent to fractions with denominators that are powers of 10. Okay? Let me show you the equivalent fraction for each of these examples and see if you notice some patterns. So the first decimal is referred to as 0.3. Okay, so I'm going to say that 0.3 is equal to the fraction 3 over 10. The next fraction is referred to as 0.56, so I'm going to say that that's equal to 5/6 over 100. 0.123 is equal to 123 over 1,000. The next one is equal to 4,455 over 10,000. 5.7 is equal to 5 7/10. 1.23 is equal to 1 23 100ths. 81.456 is equal to 81 456 1,000ths. And minus 96.71 is equal to minus 96 71 over 100. Okay, so notice that some of the equivalent fractions were mixed fractions. Notice that they all involved a denominator that was a power of 10. Okay, so some obvious questions are, how do we know what the numerators are and how do we know what the denominators are? Okay, notice that all of the numerators of the equivalent fractions is the piece to the left of, the piece to the right of every decimal. All right? So the first one, 0.3, there's just the number 3 to the right of the decimal, so the equivalent fraction has a numerator of just 3. The 0.56 is equivalent to a fraction with a numerator of 56, and on and on. All right? So that's how we can determine the numerator. How do we determine the denominator? So the denominator is a power of 10, such as 10, 100, 1,000, 10,000. The denominator, the number of zeros in the power of 10, is going to be the number of digits to the right of the decimal point. So 0.3, going back to the first one, there's only one digit to the right of the decimal point, so I'm going to have a denominator of 10 in the equivalent fraction because the 10 only has one zero. Okay? Look at the 0.4455. There's 4 numbers to the right of the decimal, So the equivalent fraction is going to have a denominator of 10,000 because 10,000 has 4 zeros. Okay, so convince yourself that now you can see why all the numerators and denominators are what they are. And then for the examples with respect to mixed fractions, the integer portion is the piece to the left of the decimal point. All right? So now let's see if you can find the equivalent fractions to a few examples of decimals now. So 0.97. Would you please pause the video and try to figure out what the equivalent fraction is to 0.97? Okay, I'll go ahead and tell you now. It's 97 over 100. What about 1.34? Go ahead and try to do that now. Okay, I'll go ahead and work that out now. So that's equal to 1 34/100. Okay, what about minus 71.9311? Would you please convert that to an equivalent fraction? Okay, that one is equivalent to minus 71 and 9,311 over 10,000. And I hope you got all of those correct. Okay, now let's go in the other direction. So, what is the decimal that is equivalent to 71 over 100? Would you please pause the video and try to determine that now, please? Okay, so that is equivalent to 0.71. Would you please now try to figure out the decimal that is equivalent to 4 and 152 1,000ths? Okay, so do that now. Okay, so I hope you got 4.152. And finally, what decimal is equivalent to negative 11 and 4/10? Do that now, please. All right, and I hope you got negative 11.4. All right, let me just make a few more comments about decimals in this introduction. So 0.56 is equivalent to 56 over 100. Now, convince yourself that it's also equal to 5 over 10 plus 6 over 100. Okay? It's for this reason that we refer to the first number to the right of the decimal point as the 10th number, okay? Because when you express it as a sum of fractions involving denominators that are powers of 10, the 5 will go above a 10, okay? So the 5 over 10 is referred to as 5/10. And the 6 in the decimal, the original decimal, that's referred to as the 100th number, because in the equivalent sum of fractions, the 6 is over 100, and 6 over 100 is referred to as 6/100ths. Okay? Here's another similar example. Okay, 0.123, that's equal to 123 over 1,000. That's also equal to 1,000th plus 2/100ths plus 3 thousandths. Okay? So once again, the 1 in 0.123 is the tenth number. Okay? The 2 is the hundredths number. And for this example, 3 is the thousandths number, because 3 over 1,000 is referred to as 3 thousandths. Okay? The way that you could also say a number like 4.9 is you could say 4 and 9 tenths. Okay? The decimal, you say and to represent the decimal. So again, 4.9 would be 4 and 9 tenths. Okay?